without further ado, here goes Steve Klabnik.
Hi everybody, I'm Steve. I am standing between you and the parties, so I apologize. This is my Twitter handle. You probably shouldn't follow me. I will be talking today about two programming languages that are both very near and dear to my heart, Ruby and Rust, and how to make the two of them play together. So I like to joke that I only work in languages that start with RU nowadays, so that's what I'll be doing going forward. I have some slides here that I've been experimenting with different ways of doing presentations over the years, and so this version of my slides is called raw markdown files, because we're programmers and we read lots of raw markdown files. So I have sort of slides, and then I'm going to show you a whole pile of code. So that we're going to start off with this and then sort of transition to that. So all Vim for this presentation, basically. Okay, so I have sort of three different things here that we're going to talk about today. The first one is systems programming, quote unquote. And the second one is Rust, and then Rust making heart eye emojis at your favorite programming language. I've sort of done some variants of this talk at like a Node conference and like Python stuff. So it's not just about Ruby as well, although because we're all Rubyists, I'm going to ignore those languages and just talk about Ruby. But the fundamentals apply to like whatever programming language that you're interested in. Okay, so there's this thing called systems programming, and nobody knows what it is, and everyone then misunderstands each other and argues with each other. Words are hard. I like this definition of system programming that Yehuda Weikatz made up, which basically is when it actually does matter, which is sort of nonsensical, which is one of the reasons why I like it. We in Ruby world like to talk a lot about how most of the time a lot of things don't actually matter. So people will say Ruby is really slow, and we're like, cool, the database and the network are going to be slower than Ruby, so it doesn't matter that Ruby is slow, it is fast enough. Ruby uses a lot of memory. That's okay, memory is cheap. You can get a gigantic X1 large on Amazon or whatever, and it's fine. But a lot of languages or a lot of applications or things that you're doing with computers, it does actually matter. So that's really nice when you can ignore these kinds of things, but sometimes you have a problem or a domain or like a piece of software you're trying to write where the amount of memory that's used is really important, or it actually has to be fast because a 2x speed difference is the difference between your process taking a week or taking 2 weeks. And sometimes that means control over various things as well. And so that's kind of the way that I like to think about systems programming, is when you need to actually pay attention to the details. So this, I'm going to rearrange some, the sizes, it gets a little messed up, I guess. Okay, so another thing about sort of systems programming is that people tend to think of C and dudes with beards who get very angry and are generally unfriendly with people. And so part of this is because we sort of mythologize low-level programming and think that it's somehow harder or more difficult, and that people that do lower-level programming are like better somehow than people who like just do Ruby or just do JavaScript or whatever. And that's bullshit. Everybody is good at like different kinds of things. I'm good at some things and I'm bad at a lot of things. And I know several people who think that low-level programming is actually easier than web programming. Like when you talk to them, they're like, assembly instructions do exactly what it says on the tin. It only does these 8 or 10 things. You take a markup language and a full Turing-complete programming language and a styling language that no one knows how to use, and wrap them up and send them over the internet to someone on the other side of the world that's running a totally different computer, and like you think that's easy or something. Like web programming, we do ourselves a disservice when we say that like web programming is easy, because it is actually incredibly complicated. And so you might also find that if you've never tried lower level programming before or system style programming, that you might be one of those people that finds it to be actually easy. So don't get discouraged. This is just a more general advice. Any sort of programming thing that you want to get into, don't listen to people who tell you that it's hard, because it might just be a thing that's hard for them and not for you. And so how this ties into Rust is that Rust and its community generally is here to help you learn system stuff. So we, as sort of like a core value, really, really appreciate people who have not done low-level programming before, and we want you to have Rust be your first experience with lower-level programming languages. If you come into our IRC and you ask a question that is basic, we will answer you and smile rather than call you stupid, because nobody likes to be called stupid, yet here we are, the internet. So we're not here on the internet right now, but whatever, it's fine. So anyway, learning this stuff is it's fun. It's a good time. I feel like I'm a better Ruby programmer after having done systems programming for the last couple of years. So whatever, it's a little cut off, it's fine. So we say that Rust is a systems language that's focused on three things: safety, speed, and concurrency. And one way of thinking about programming languages, I have this little ASCII axis, which is kind of hard to say actually, ASCII axis, ASCII axis. There's this trade-off that we have between speed and safety, or control or no control, dangerousness and slowness. So a language like C is generally very, very fast, but is also terrifyingly sharp of a tool, and you will cut yourself sometimes. And you get an extreme amount of control, probably more control than you want a lot of the times, over the way that your program executes and all of the details about your program. Whereas a language like Ruby, you get an extreme amount of safety, and by safety what I mean is things like you can't get seg faults in Ruby unless you're using a native extension, which is a thing we'll be talking about shortly. But like pure Ruby programs cannot seg fault. You can't have certain kinds of other like memory problems, and that's due to Ruby having a garbage collector. But that also means that Ruby is generally a slower programming language. And that doesn't necessarily mean that it's bad. That's just the way things are. And you don't have very much control over the details of how your program operates. You're sort of at the whim of the implementers of MRI or JRuby or whatever. And I like to put Java in the middle down here. A lot of people like to talk trash on Java. I think we all need to get over it, especially in Ruby world. But Java is like this weird middle ground where like it's definitely more safe than a language like C, and it's a little more slow, but it's actually still pretty speedy. So programming languages generally fall on this axis somewhere, and Rust's goal is to completely destroy this axis. So we want a language that's as safe as Ruby that is as fast or faster than C. And there's always a trade-off. So like if I tell you that things magically are just better, I'm probably lying to you. So the trade-off in this instance is that we have lots of compile time checks, and so satisfying the compiler is a little tough at times, or it's a struggle as a new programmer. So if you haven't worked in a statically typed language before, the amount of things that Rust checks at compile time are pretty intense, and that's really, really awesome because it means that we can generate like very low overhead, super fast code, but it also means that you'll be like, this program should work, compiler, why are you yelling at me? Like, it just compile it, damn it. And so, as a small aside, lots of people like to call this fighting with the compiler when they're like struggling. This is like a very common intermediate thing. In Ruby world, it's like metaprogramming is the sort of test if you're an intermediate or advanced Ruby programmer to me. Like if you've read metaprogramming Ruby, that's when you like level up, when you're like originally writing Ruby, and then you like talk about eigenclasses and your brain melts and like, you hopefully come out on the other side a little bit better. So in Rust, it's this fighting with the compiler phase. That's our like equivalent of metaprogramming. And a lot of people say fighting. I don't like to call it fighting because I think that sets up an adversarial relationship that's not true. I like to think of it as more your good friend telling you that you're about to do something really stupid and you probably shouldn't. Like, I know that I've had friends tell me like, hey man, that's a bad decision, you probably shouldn't do that. And you're like, okay, thank you for looking out for me. That's the way I feel about the Rust compiler, is that it's not fighting with me, it's telling me I'm about to do something terrible and preventing me from doing so. Okay, so I have a bunch of code. That's some background stuff about Rust. It's hard to like teach a programming language in 45 minutes, so I'm just going to kind of randomly explain some syntax to you as I show it to you, but this is not really so much a tutorial on Rust as it is like integrating Ruby with weird other languages. So it's not really about the details. Let's see. I'm going to do a new terminal window here. I forgot to set up my second terminal. Woo. Oh, F11, yeah. I usually use xmonad, but like xmonad and multiple projectors is sadness. So prepare for me to mistype a lot of keyboard shortcuts because I have these things ingrained in my head, and now I'm in GNOME instead. It's Rust example. And let's change this. OK, so I have sort of 4 components in this directory that I'd like to show you. This is a little small. Let me make this a little bit bigger. So there are a number of different ways to integrate Ruby and Rust. And part of this is because essentially Ruby knows how to talk to C. A lot of people say that C is like the Latin of programming, like it's sort of the language that all other things come from. And so basically the way that you get Ruby to talk to other languages is you make those languages pretend that they're C. So Ruby thinks that it's talking to a C program, but actually it's talking to a Rust program instead. So what that means is there's sort of these 2 edges. So you have like Ruby takes its stuff and converts it into C stuff, hands it over to Rust. Rust takes that C stuff and converts it to Rust stuff, and then vice versa. So you have this kind of like bridge effect. And so I'm going to show you a couple of different ways to make that work. And then also I have this MRusty directory is about MRuby. So MRuby is super cool. Has anybody played with MRuby or like looked into it lately? You know what it is? OK, only a couple of people. MRuby is awesome. We'll get there. So I'm going to show you the like really hard, intense way first, and then the like easy way second, because that's just what I want to do. So the end result here, I have this make file. I'm going to type make, and it's going to compile a whole bunch of stuff. What I'm going to show you is how to get Ruby and Rust to print out hello world twice and then a 5. And we're going to journey through a whole lot of stuff to get there, but this is kind of the end result. So the first thing that we need to do is actually set up a Ruby gem at all. So in this particular example, I have this Ruby gem. And I don't know how many of you have authored gems before. Ruby has really wonderful tooling for making gems, and it's pretty fantastic. I always have a good time making lots of gems. And so there's standard conventions that depend on where your code goes. So most people know about the lib directory is where your Ruby code goes. But if you have a C extension, is what they call them in Ruby parlance, there is also this Ext directory inside there. So the actual source code of this gem is require rust example / rust example. Now, this is repeating, which is kind of a little weird, but it's about the way that a Ruby gems compiles C code when you have a C extension. It's just way easier to follow the naming conventions, even when they feel a little dumb. So, because of things I will show you in a second. So this is literally all of the Ruby code that's in this gem is require this stuff that actually turns out that it's written in C. I guess I lied. It's not all of it. There's also a version 0.2.0 in there as well. But that's all of the Ruby code. Everything else happens in this Ext directory. So I'm going to go into there. And so in the Ext directory, there is this Rust example folder, which is conventional. And that's why the require line said require Rust example / Rust example, is because this is the directory. So it works the same way as other stuff does. And then in here, there are some files. The first file that's really important is extconf.rb. How many of you have ever messed with extconf before? Yeah, so you all know that it's like magic that no one understands, right? You're like looking through some source code. So here's what happens. extconf.rb is this DSL. And it's a DSL that was originally put in Ruby gems. And what it does is you require mkmf, which stands for make file, clearly obvious from that abbreviation. And then you say, hey, I have a particular library. Just like all Ruby DSLs, this is actually Ruby code, even though it's just sort of calling these two functions. So I have a library called Rust example, and then you also give it an entry point. So whenever you have a native extension, Ruby calls a function when you load that extension up. And so you have to tell it what the name of it is. And so the conventional name is the name of your library _init. So we say, hey, here's this library I'm going to define. Here's the function to initialize it. And then you write this create makefile line. And so what happens is when you actually build the gem, so I'm actually going to go upload directory. So if I do rake build, for example, oh, I already did it, so that doesn't show cool output. You know when you install a gem that has a native extension and it says something like building native extension ... and then it sits for a while? This mkmf stuff is what's happening when that ... is going on. So usually that output is totally hidden. And what that actually does is this extconf.rb file, you basically run it, and it makes this make file. And so those couple lines generates all of this junk that is clearly very readable and debuggable if you get it wrong. Yeah, we're 30% of the way through this file. It's ridiculous. And so all that does is it tries to compile this Rust example.c file. So this is why I said that this is the hard way. So, bless you. We're actually not just writing some Rust code for this gem, we're also writing some C. And here's the reason why. Ruby FFI is nice, but the problem is that Ruby's interface isn't so much like a well-designed, thoughtful interface in how to interpret with Ruby. It's more like, here's the header file for the interpreter, go nuts. We'll hopefully not break any of your stuff. And so the problem is that there are a whole lot of macros written in C that are basically just easier to write a small C wrapper rather than trying to re-implement them in Rust directly. Now there's an answer to that, which is sort of what the MRuby stuff is about, but I'm kind of showing you the most low-level, annoying way of doing it first, and then we'll get better in the future. So this is a C program that includes ruby.h and then defines these three functions. So hello Rust, fill slice, and num are three functions that are going to be defined in Rust world. So the extern keyword in C says this is an external function from somewhere else. So we're going to load it up that way. And then here is a couple of these functions that are sort of implemented in C, kind of. So you know how in Ruby everything returns an object of some kind, right? So this is also displayed in the C interface. So value is, again, this weird C macro that expands to a bunch of C code that is like a Ruby object. So this C return type is actually all these details about Ruby functions. So this calls our hello Rust function and then prints to the screen and returns qnil, which is nil, but like in C instead of in Ruby. So that's like what Ruby calls it internally. And so I have some other functions here. They don't really matter that much at the moment. But here's the last bit of annoyingness about making a Ruby C extension. So remember how we said there was that init Rust example function that was like the loading point? So this is actually defining it. And you have to name it with a capital I in it, and then an underscore, and then the rest of your stuff, which is looks really ugly to me. It's really weird, because Ruby is so focused on aesthetics most of the time, and then you have to have this really odd naming convention, but whatever. So here, we have these couple of functions. So Rust example equals RB define module Rust example. This is literally like saying module Rust example in Ruby, but via the C extension rather than the Ruby extension. And then we define a singleton method by hooking up the name of the C function to the name that we want of the Ruby function to be, and then we do all those things and we're done. So yeah, like I said, it's really annoying, but what's cool about this is it means that you can generate a gem that has all this stuff built in, and so you can actually distribute the gem pre-compiled for a particular version. So So I don't know how much you've dealt with binary gems before, but you can see on rubygems.org, and I mean you could see if the font wasn't light gray on white on this projector. I actually really like the new rubygems.org redesign, but I just realized it's in this tiny font that has no contrast whatsoever. And so you can actually see that this has x86-64 Linux and x86-64 Darwin 13. And so you can actually have this stuff pre-compiled so that your users don't need to do the compiling themselves, yada yada. And so that's what doing it this way kind of enables. And it's also useful if you want to distribute it to other people. But if you're building your own application and you're not trying to share this with people, it ends up being much easier. Anyway, I'm going to show you some Rust now, how these functions are actually implemented. No. Yeah, terminal. Okay, so in Rust, we actually have very similar tooling to Ruby, and this is one of the things that ends up being awesome about Rust. We basically literally paid Yehuda to write bundler for Rust. because we're just like, we love Bundler, it's a great package management system, let's just like steal it wholesale. And so we call it cargo rather than Bundler. Because Rust calls packages crates, so cargo is how you ship your crates to other people. And so we also have a source directory, just like in Ruby you have this lib directory. And then cargo.toml is the equivalent of your gem file. So in cargo.toml, we sort of, just like we define stuff for gems, we say here's the name of this particular package and some authors, and then the name of it. And in this case, we want a static library and a dynamic library because I'm going to be showing you the two different ways of making these things, and then any dependencies that are involved. And OK, so here's a bunch of Rust syntax. I'm going to turn off my syntax highlighting. So one of the really cool things about Rust is that because it is a low-level language, you can basically get rid of the standard library and embed it in almost anything. Like I said, it pretends to be C, literally. And so what this means is we can add these annotations. So this is a little more noisy than regular Rust code because we have to basically say, hey, please pretend that you were C for all these functions. But this combination of no mangle and extern C says, hey, this function, hello Rust, is going to pretend to be a C function instead of a Rust function. And that's what like enables Ruby to be able to know how to call the Rust function itself. And so in this case, the hello Rust function just returns this particular string as a pointer, and we need a null and end because of C. And there's a whole bunch of other stuff in here. It doesn't actually matter at the moment. They're very, very simple functions that, like I said, this particular one returns this string hello world. I wrote some documentation for this one, so it's a little complicated. But this basically just like copies hello world into another string, and this final one just returns the number 5. And it's because this is a demo about showing how they communicate rather than being in a like super extensive, here's a bunch of Rust stuff. Later, we're going to see this 5 appear in a Rails app, actually, as well, which is kind of cool. OK, so just like we can do the like rake to build a gem, we do cargo build -- release. Yeah, I typed it right. Why did it not do anything? Oh, it's because I already built it. It's like, you've already built the thing, why would I do anything else? So you just type cargo build, and it knows how to build and generate all that stuff. So you don't have to deal with make files. You get a very bundler-like system for writing your Rust code instead of the normal C terribleness / scariness. OK, so we have this gem now. What can we actually do with it? I'm going to copy and paste this because so yeah, I forgot the R on the Ruby. Thank you. So we can actually use this particular gem by calling Ruby and passing the -i to include the lib and ext directories, and then -r requires the Rust example gem. A long time ago, I almost thought that I found a bug in Ruby. So if you go to Ruby's source code, I'm just going to go off on a tangent real quick because this is one of my favorite stories. If you go to Ruby's source code and you look at all of these files that are freaking just sitting in the top level directory, because I don't know why they do this, there's this file that I found very suspicious, and it's called, it's not here anymore. Oh no, is my story done? It's in lib maybe. This is totally still here. It's here. Ubi gems. They moved it. OK. So there's this file, and it's called ubigems.rb. And I was like, that has to be a typo. What's going on? And you click on it, and you get this header that's always, copyright 2006 by Chad Feiler, Rich Kimler, Jim Wyrick, and others. Like, it's awesome. But all it does is requires Ruby gems. And I was like, what is going on? This has to be a mistake. And it's like sort of almost Easter egg. So what you can do is you can say ruby-r and then require a gem. But if you type ruby-r Ruby gems to do require Ruby gems, that looks kind of like dumb in a certain sense. So what they did was they made Ruby gems, so it's just -r Ruby gems, basically. And that's actually like in Ruby. So that's how I learned about this, was I literally tried to submit a patch being like, what's this file doing here? Anyway, so we can require the Rust example gem, and then -e will let you, instead of it being like a interpreter or a REPL, it will let you say execute the string. So in this case, now that we've defined all this stuff hooking these things up, the Rust example module has a function hello, and it will return that string. The Rust example make hello will do that string, and then puts Rust example.number, prints it out. And so that's how we get our hello world in 5, by transforming through Ruby to C to Rust to C to Ruby and back again. So that 5 went on a long journey to get printed on my terminal. Okay, so that was the super terribly intense low-level way of doing it. In my last couple minutes here, I want to show you 2 much more easy and sane ways of doing it. The first one being a Rails app. So I called this Rails app Rails because I got lazy and names are hard. But this Rails app has almost nothing in it. It has a welcome index action. And in the welcome controller, it requires a Rust example. And then in the index, it says @number equals Rust example.number. And then get a number from Rust. The number is, and prints out the number. And so I'm gonna, oh, it loaded a totally different. Get a number from Rust, the number is 5, it prints this out. So the way that it does this is a little different and better. Oh. Gnome, why? Okay, so the way that it does this is the lib directory. So you know how the lib directory in a Rails app is kind of just like, I'm too lazy to make a gem out of this already kind of thing? So that's what I did. So there's this Rust example.rb, and instead of doing all of that mkmf, C, mapping, header file shenanigans, it turns out that there's a really awesome thing in the Ruby standard library called fiddle. And what fiddle lets you do is it lets you basically load up a C shared object library and say what functions are actually in there, and then just lets you call them as Ruby code. So instead of all of that C crap, you could instead do this. You define a Rust example class and a number method, then you call the DL open method a fiddle, and you point it at where the SO is, and then you can say this fiddle function is called Rust example, and it has the num function. The empty array there is because num takes no arguments, and then fiddle type int says it returns an integer back. And then the fiddle library will actually handle doing all of that wrapper junk that I showed you a couple minutes ago, and then that gives you back a proc that you can just call. And so this ends up doing the same thing as all of that, but is way, way easier. But I like to understand how it works and then use the convenient stuff on top. So that's why I showed you the hard way and now the easy way. So this is a significantly easier way that you could integrate Rust code into Ruby code and do stuff this way. This is actually how doing the C pre-compiling thing was so annoying and complicated. Yehuda in Skylight, their product that they sell over at Tilda, it's actually written in Rust, their Ruby gem. And what they do is they have a before install hook that downloads the shared object file from their servers and then uses fiddle because it ends up being a little more reliable than the low-level stuff. So this is a really, really cool way of integrating Ruby with, again, anything that can pretend to be C, not just Rust. So fiddle is really awesome. Okay, so that's the Rails app. And then I want to show you this MRuby real quick. So only some of you said you knew about MRuby. MRuby is kind of like Matt's new project to a certain degree. It's what he focuses a lot of his time on nowadays. And basically, MRuby is kind of like, it's Ruby, but it's more lightweight. So it doesn't share all the same features that MRI has, but the key thing that's cool about MRuby is that you can embed it inside of other programming languages. So you know how people use Lua, where they embed Lua and something else to get a little bit of scripting into your app? So MRuby lets you do that with Ruby instead. And so this is really cool and useful. And so it's neat because it is Ruby, but not 100% of Ruby, but it's a lot smaller. And it's just real cool. So this really awesome person made a library for Rust called MRusty that hooks up MRuby to Rust. So what this means is, and this is actually one area where I think that MRuby is really, really important. So we've seen a number of companies over the years that have originally used Ruby move away to other languages because they need to distribute command line applications. And I don't know if you've ever tried to distribute a command line application written in Ruby before, but that is the accurate sound you should be making. So the two big ones I can think of off the top of my head are Heroku and Vagrant. They both were originally written in Ruby, and eventually they decided to move on with their lives, and they rewrote them both in Go, actually, both times, because it's significantly easier to make command line applications. And so one of the things I really love about MRuby is that it sort of enables you to do these kinds of things, but in Ruby instead, because I love Ruby and I'd like to write things in Ruby. So the MRusty project lets you sort of write shared command line applications in Ruby, but also in Rust at the same time. And it also is a much nicer experience than the low-level makefile stuff I showed you before. So here's how this works. And this is probably the most Rust code I'm going to show you. We bring in our project, MRusty, the name of this package, and then the main function is where all Rust code starts executing. I'm actually going to turn this syntax off. It's harder on a projector. So this let MRuby equals MRuby new actually makes and initializes a brand new MRuby interpreter. And now you have access to it from your Rust code. And when you install this extern create MRusty, it actually downloads a copy of the MRuby source and builds it for you so you have one locally. So there's no dependencies on outside things at all. And so here we make a Rust structure called cont for container, and it just holds a number. And then there's some shenanigans. It's actually a little harder without syntax highlighting and because this font is so big. But we can say, I have this class, and I'm going to use that Rust struct to define this Ruby class. It's going to have an initialize function that takes a number, a 32-bit integer, and it starts off the container holding that value. And then you can get the value by printing out a fixed num from it. And then it actually also includes an rspec style macro as well. So you can actually then write what is effectively rspec code, although I believe the MRuby version of rspec doesn't have all of the features that real rspec does. Sam is shaking his head, as he usually does. And so you can also test your stuff here. But here's what's really cool. So that MRuby, when I said that was a handle to a Ruby interpreter, you can call mruby.run and then pass in a string of Ruby code, and it will just evaluate it in that Ruby interpreter and give it back to you in the Rust. And so here we can print out, in this case, we have this container around a 3, so it's going to print out the 3 again. But we can also just include arbitrary Ruby code. So here I require a greeting file, and in this greeting.rb I just defined a really simple class that says hello there. And so you can write all of your files in Ruby and then sort of bring them in this way. And it actually also includes a REPL, so you can actually start up a new IRB instance inside of your command line program if you want. And so I'm going to compile and run this. You can see it taking a minute to compile. But basically, what this ends up doing is it ends up giving you a single program that has almost no dependencies. You can just copy onto any other computer and run that stuff. And so I think that this is a really exciting way of bringing Ruby back into a space that it has historically done really bad at, because packaging Ruby up for command line things has not been that great. So anyway, that's a couple of different ways to integrate Rust and Ruby together. I thought that this, yeah, there we go. It's finally done. I was like, come on, compiler, 3 and hello there. So you can see Rust and Ruby working together in that fashion. So in conclusion, close this one. OK, so I really love Ruby. I literally have a Ruby tattooed on my body. I've been doing more Rust than Ruby in the last couple years, but that doesn't mean that I don't like Ruby anymore. And so one of the things that I think that is awesome about learning Rust is that you don't have to stop using your old programming language. There's a whole lot of people that think that you can only use one language at a time for some reason, instead of enjoying multiple different programming languages together. And so you can write packages in Rust for Ruby, and then you get the best of both worlds. So thank you so much for having me, and I would be happy to talk more details about this with anybody else the rest of the conference. So, thanks. I don't often do questions, but I guess I'm a couple minutes early, so do we want to do some questions? Cool. What's up?
Where's the tattoo?
It's right here. So I got this ruby, but it's got this skeleton holding this ruby, and so when I originally got it, I also have a Perl camel farther up my arm, because I did Perl before Ruby. People have been asking me when I'm getting a Rust tattoo, and I joke, like, when I don't program in it anymore, that's when I'm going to get the tattoo. When I originally got the tattoo, and it's got this skeleton holding it, Jeffrey Grosenbach was like, is that DHH holding that ruby? And like mentioned him in the tweet or whatever, and he didn't reply. So it's not confirmed nor denied that that's skeleton DHH tattooed on me. Yeah. Any other stuff? Sweet. Let's go party or whatever, wine tasting / cruise / stuff. Yeah. Yeah, I don't want to steal.